x's, which is 0.4, minus 2. Okay, and then we get negative 1.6. Okay, and then that tells me my slope that I'm taking on this new trajectory. That's my redefined trajectory. And then that delta y, the change in y will be whatever my slope is, negative 1.6 times my delta x at 0.4. And I'm being careful on this one. I already have it on my screen, but you want to make sure you put these in here really carefully because you're only doing 2 of them, and be extra careful as you go. Negative 0.64. And then same thing as you take your current y, which is your old y, 4.2. You're going to take it, this adjustment of y, 0.64 down. And then you get your 3.56. Okay, we made it. That's 2 steps, 2 leaps. That's actually our end goal. Where we ended up is 0.8 and this 3.56. Okay, that's our destination. We got there. It's funny, like cannot make that a point, can I? So what we found out is y of 0.8 is about 3.56. We know that's under the actual value, but it's an okay guess. We're just sitting right here. So this little point right there is at the point 0.8, 3.56. And it's under what it should be on the actual axis up above. And that we'll find out in just a minute how much it's under. Okay. Your first foray into Eulers' method. We should do it again and get really fast at it. You ready? On your marks, get set. I can't turn my page. Go. So we should try it with this next one. It says solve the differential equation. In example 2, not example 1. And it says 5 equal steps to approximate when x equals 1.5, and we're starting at x equals 2. So here's how I got x. I write it in a bold color. This is going to take a little work. I'd team up if you want to. Make sure your life easier if you can. But it's a chance to practice. You want to do one long one in your lifetime. And then you also want to input that program that I give you that's on my Google Drive, because you don't want to do it too often when it's really big. It's a little painful. So these are the components. You want to start remembering what you're finding. And then delta y. Okay, these are all the components. And if you go 5 steps to get there from 2 and you're going to get to 1.5, did you guys get the delta x, what it's going to be? You're welcome to use the formula. Delta x is always b minus a over n if you just want to keep using that. But our end goal is 1.5. Our start is 2. And we're taking 5 steps. So 0.5 divided by 5, it's 0.1. And it's negative because it's decreasing. So you're welcome to fill in all the x's right at the get-go. You can do that. So it'd be 1.9, 1.8, 1.7, 1.6, 1.5. You can get there. The answer that we're shooting for is that y value down at the bottom that I just highlighted. That's where you're headed. I'll get you started so we're all in the same boat. dy dx, I have an x and a y to plug in this time. So you want to be careful to plug them both in. So that means 2 times x minus y. So, and I think, oh, I put, it's not a negative 2, it's just bad handwriting. So it's 4 minus 3, it's 1. And that slope that we just got, this is our m, times your delta x, which is negative 0.1. That'll give you your change in y. So my first change in y, the first drop is negative 0.1. which takes me from 3 down 0.1 to 2.9. That's my starting place for another iteration. Let's start over. That carries down. Then you have another new x, so 2 times 1.9. Keep your calculator in hand because you don't want to do this by hand. Just keep it out there and go 2 times 1.9 minus 3. Don't be shy. It's okay. It's 0.8. And then you go 0.8 times negative 0.1. And just be bold. It's always going to change by a decimal place on here. That's one way you can shorten this a little bit. And that means 2.9. Take away that new delta x, or delta y, 0.08. 2.82. And it just keeps going. You'll never have one this big again to do by hand, I promise. But it'll get the idea narrowed down. Okay. So let's get another chicken dinner. Winner, winner. Can you make it to the end? Austin, you looking at which one you looking at? This one right here? This one?
Yeah.
So let's see. 2 times 1.9, my current x value, minus 3.
So when you do minus 2.9?
Ah, so this is minus 2.9. Yeah. Thanks.
Solve. So just 2x minus 1.
Looked at the wrong row. Point 0.9. That's better. So that's 0.9 to 0.1, so 0.09.
2, 3.
And then 2.9 minus 0.09 changes that one a little bit. 2.81. Way to go, Austin. That's better.